NASA's interest in asteroids, particularly those approaching Earth, has been a significant part of its mission for many years. This interest is driven by the need to understand these celestial bodies better, identify potential threats to Earth, and explore the possibilities of utilizing space resources. The Asteroid Redirect Mission. The Asteroid Redirect Mission, ARM, was one of the initial proposals by NASA to interact with a near-Earth asteroid. The mission aimed to develop a robotic spacecraft to visit a large near-Earth asteroid and collect a multi-ton boulder from its surface. However, this mission was discontinued, and the focus shifted to other asteroid-related projects. The DART mission. One of the most notable missions in recent years is the Double Asteroid Redirection Test, DART. This mission marked the world's first planetary defense technology demonstration. DART successfully impacted its asteroid target, Dimorphos, demonstrating a viable mitigation technique for protecting the planet from an Earth-bound asteroid or comet. The DART spacecraft was guided by the Didymos Reconnaissance and Asteroid Camera for optical navigation, DRACO, and a sophisticated guidance, navigation, and control system. These systems enabled DART to identify and distinguish between two asteroids, targeting the smaller body, Dimorphos. The impact of DART on Dimorphos was intended to alter the asteroid's orbit around its larger companion, Didymos. Researchers expect the impact to shorten Dimorphos' orbit by about 1%, or roughly 10 minutes. Precisely measuring how much the asteroid was deflected is one of the primary purposes of the full-scale test. The DART mission also displaced over 2 million pounds, 1 million kilograms, of the dusty rock into space, providing valuable data for further analysis. The momentum transferred when DART hit Dimorphos was roughly 3.6 times greater than if the asteroid had simply absorbed the spacecraft and produced no ejecta at all, indicating the ejecta contributed to moving the asteroid more than the spacecraft did. The NEO Surveyor. Looking ahead, NASA plans to launch the Near-Earth Object, NEO Surveyor, a space-based infrared telescope designed to survey the solar system for potentially hazardous asteroids. The NEO Surveyor spacecraft will survey from the Sun, Earth L1, inner, Lagrange point, allowing it to see objects inside Earth's orbit. Its mid-infrared detectors sensitive to thermal emission will detect asteroids. As of December 2022, NEO Surveyor is expected to be launched no later than June 2028. The role of SpaceX Starship. The SpaceX Starship is a fully reusable transportation system designed to carry both crew and cargo to Earth orbit, the Moon, Mars, and beyond. As the most powerful launch system ever developed, Starship will be able to carry up to 100 people on long-duration, interplanetary flights. The Starship system consists of two parts: the Starship spacecraft and the Super Heavy rocket. The spacecraft is capable of carrying crew and cargo to various destinations and is also capable of point-to-point transport on Earth, enabling travel to anywhere in the world in 1 hour or less. The Super Heavy is the first stage, or booster, of the Starship launch system, powered by 33 Raptor engines using subcooled liquid methane, CH4, and liquid oxygen, LOX. Super Heavy is fully reusable and will re-enter Earth's atmosphere to land back at the launch site. The potential use of SpaceX Starship to reach an Earth-approaching asteroid represents a significant step in human space exploration and the utilization of space resources. NASA has been given a presidential directive to land astronauts on an asteroid by 2025, a mission that some say represents the most ambitious and audacious plan yet for the space agency. The human mission to an asteroid is seen as an extremely important national goal, as it will focus both NASA's and the nation's attention on extending human capability beyond Earth/Moon space and into deep space. This is an essential capability in order to ultimately get to Mars, and a relatively short mission to a near-Earth asteroid is a logical first step in establishing a deep space human capability. However, there are several challenges to such a mission. One of the main issues is the lack of understanding about asteroids. Scientists are not sure how different asteroids are put together, whether they are a rubble pile or solid surface, and are not certain how to orbit and land on one. Another challenge is the lack of a launch system capable of reaching deep space. Despite these challenges, NASA has already made significant strides in asteroid exploration. In a historic first, NASA successfully altered the orbit of an asteroid, Dimorphos, by crashing a spacecraft into it. This mission, known as the Double Asteroid Redirection Test, DART, was an important element of NASA's planetary defense plan. In addition to the technical prowess required for such a mission, there are also human health and performance considerations. The 5 hazards of human spaceflight include radiation, isolation and confinement, distance from Earth, gravity or lack of, and hostile/closed environments. Despite these challenges, a human mission to an asteroid could provide several benefits. It would add to our body of knowledge about these interesting and occasionally dangerous bodies, and benefit our interest in protecting the Earth from asteroid impacts. Planning 6-month round trips to these ancient bodies will teach us a great deal about the early history of the solar system. How we can extract the water known to be present on certain asteroids, techniques for deflecting a future impact from an asteroid, and applying this deep space experience toward human Mars exploration. Click here to watch how you can survive on Mars with Elon Musk. If you enjoyed this video, please leave a like and subscribe to our channel so that you don't miss any of our future videos.